All right, Algebra 2, here we go. 9.3, geometric sequences. The essential question here is, what is a geometric sequence? Okay, by definition, the terms are multiples of the previous term, and that multiple is R, called a common ratio. Okay, the arithmetic sequences we just did, you added a common term each time. Now we're multiplying by a common term. 3 times the 2 is 6, 6 times the 2 is 12, 12 times the 2 is 24. You get the picture there. R is 2. You're multiplying by 2 each time. That's what makes it a geometric sequence. Okay, we've got our two formulas just like we've been doing, recursive and explicit. Remember the recursive, you have to know the term before. So if A1 is some value A, then A to the n is going to be A to the n minus 1, the one before it, times the R. Okay, just like here, you want to know that one, you take 12 times 2, you take the one before it, multiply by that R. Take the one before it, multiply by the R. Okay, the explicit, it doesn't matter, we can find the 100th term by just plugging in 100 for n. A to the nth equals A1, the first term, like 3, times R to the n minus 1. Okay, so here you're going to get an exponent. Alright, so you got to be careful with that. Let's take a look at some examples. Alright, first question, is this a geometric sequence? 3 times 2 is 6, but 6 times 1.5 is 9. So we don't have a common R, so no, this one isn't. Not like the first one we did. Okay, what about here? To get from 3 to the 5th to 3 to the 10th, you multiply by 3 to the 5th. To get from 10 to 15, you multiply by 3 to the 5th. So yes, this is geometric, and our R is 3 to the 5th, and the first term is 3 to the 5th. Okay? If you want to know the 10th term, okay, 4, 12, 36, rather than going all the way out and trying to do them all, let's just do it as an explicit formula. So I can see that I'm multiplying by 3 each time, so that's my R. My first term is 4, so I'm going to plug it in. Here's my explicit formula right here. So let's plug in what we know. We want to know the 10th term, so I'm calling n 10. The first term is 4, R is 3, n minus 1 will be 10 minus 1. So we get 4 times 3 to the 9th. Multiply all that out in your calculator, 78,732. Okay? Just like with arithmetic, what do you do if you're missing some terms? Okay, like we go from 2, blank, blank, negative 54. We want to fill in the blanks. So I'm going to use my arithmetic again. I know my first term. Okay? I know the fourth term. I'm not going to use the first one. I know my fourth term is 54. So the fourth term, there's my first term. I don't know R, that's what I need to find. Okay, what am I multiplying by to get those? N is 4. So I substitute in the negative 54 for my a to the fourth. I get 2R to the 4 minus 1, that's R cubed. Solve for R. Divide out the 2. Cube root both sides, we get negative 3 as our R. So when I take 2 times negative 3, I get negative 6. Times negative 3, I get 18. Times negative 3, I get negative 54, so it fits. Okay? So there's a couple of examples, kind of get us kick-started for tomorrow. When you come in here, we'll look at some more examples and some application. All right, we'll see you then. Bye.